3.5, solving systems of equation with three variables. So yesterday and the day before we've been working with three unknowns. And the first day we looked at graphing with three variables. And then yesterday we looked at solving the three unknowns when there are picture graphs. Today let's look at it when there's variables. And so we're going to start off with three equations. And step one is always to number your equations. And it doesn't matter how you number them, just number them. And so I'm going to number 1, equation 2, and equation 3. So on these equations, when you're finding systems of equations, you will always start with as many equations as there are variables. So in this case, there are 3 variables, so I have 3 equations. Before you go any further, look at your 3 equations. The first one has 3 variables. The second one has 3 variables. But the third one only has 2. This one is missing x. And so I need to come back over here. And so my goal is to create a second equation that's missing x. So I'm going to look at my equation 1 and my equation 2, and I am going to use those in order to create a third equation, or a fourth equation, excuse me, that has no x in it. And so going back to like we were doing in 3.2, and when we did the solving systems by elimination, so you're going to take the equation 1 and just write it down right now. And then you're going to take equation 2 and write it down. And so our goal is to knock out the x. That means we want to eliminate x. Right now, if I added these 2 equations, we'd come up with 3x. That's not going to help us. We need it to be where x cancels out. If I multiply this first equation by -2, that will result in an equation that looks like -2x minus 4y plus 6z equals a -32. The reason I multiplied it by -2 is -2x plus 2x will cancel out. So it's the second equation. I am just going to multiply it by 1 or leave it alone, in other words. So we have 2x minus 3y plus z is equal to a -10. And I am going to add these equations. When I add these equations, I end up canceling out my x's, and then my y's, -4y minus 3y is -7y. My z's, 6z plus z is going to be plus 7z. And then my constants, -32 plus a -10 is going to be a -42. I notice at this step that all of these terms are divisible by 7. So I am going to go through and divide every single term by 7. The reason for that is it gives me smaller numbers, and when I have smaller numbers to work with, I make less mistakes. So -7 divided by +7 is a -1. So I'm writing that as -y. +7 divided by +7 is going to be a +1. So +1x, or +1z is z. And -42 divided by 7 is going to be a -6. Now I am going to take these 2 equations, this one that I just created, and the original equation 3, and I'm going to combine those. I am going to call this new equation I did equation 4. So I'm taking equation 4 and equation 3, and I'm going to use elimination to see if I can get any other terms to cancel out. So equation 3 was y minus 2z equals 9. Equation 4 is negative y plus z is equal to negative 6. And so when I take these two equations, first step is to look to see if I add these equations, will we cancel out any variable? And when I add these equations, my y's will cancel out. So I do cancel out a variable, and so I'm just going to add the equations. Y plus a negative y cancels and gives me nothing. 2z, a negative 2z plus z gives me a negative z. And 9 plus a negative 6 gives me a 3. Well, that gives me negative z is equal to 3. And if I multiply both sides by negative 1, that solves it to where I have z is equal to something. Now that I know what z is, I can take this and use it into one of my previous equations and find another variable. So I'm just going to take it up to equation 4 and apply it in there. And so I'm going to take that equation 4, which is negative y plus z is equal to a negative 6, and I'm replacing that z with that negative 3. So negative y plus a negative 3 is equal to negative 6. Plus a negative 3 is the same thing as me saying minus 3. And so I need to add 3 to both sides to move it. And that gives me negative y is equal to a negative 3. Now, I don't want to solve for negative y, I want to solve for positive y. So I am going to multiply both sides by negative 1. And so y is equal to a positive 3. So we now have z and we have y. The only term we are missing is x. And so when I try to find x, I need to go into one of the top equations. And I just choose one, and I'm just going to choose, for my purposes, I think the first one looks like it's the easiest one. So I'm going to go on to the next page, and that first equation was x plus 2y minus 3z is equal to 16. And so we found z, and we said that z was negative 3. We found y, and found y was going to be 3. So I'm just going to plug into this equation the numbers we've already found. So 2 times 3 minus 3 times negative 3 is equal to 16. When I do the math, 2 times 3 is 6, negative 3 times a negative 3 is 9. Combine like terms, x plus 15 is equal to 16. Subtract 15 from both sides, and we find out x is equal to 1. So, when we give a solution on this, you're going to do it as a ordered pair, but it's not really a pair anymore because we have an x, a y, and a z term. So you write it in order of alphabetical order. X goes first, 1. My y was 3. And my z is negative 3. So this is my solution, that point. So let's do one more. And I know these problems are long, so it takes a little bit of steps, but the biggest thing on these is ordering your work. So on this one, we have a problem. There are 3 variables in every single one. So that means we need to choose which letter we are going to eliminate. And what I typically do is look for one where I have opposite variables, opposite signs, and there are a couple of different options. I'm deciding that I want to eliminate out my y's. And so I'm going to pair the first 2 equations, and I'm going to pair 2x plus 4y plus z equals 1. So that's equation 1. With equation 2, which is x minus 2y minus 3z equals 2. And I said I wanted to get rid of the y, and so that means I need to multiply the second equation by 2 in order for me to have something that can cancel. And so that gives me 2x plus 4y plus z is equal to 1. And then when I multiply the second equation by 2, I get 2x minus 4y minus 6z is equal to 4. Now I'm going to add those together. And when I add those together, that gives me a 4x. My y's cancel out because positive 4y minus 4y is nothing. And then my z's become a negative 5z. Z minus 6z is equal to 5. If I look at this equation, there's nothing that can cancel out. So I am done. This is my equation 4. Now I'm going back to my original one, and I'm going to choose 2 other equations. So I'm just going to take the last 2. And so using my last 2, equation 2 was x minus 2y minus 3z is equal to 2. And then equation 3 was x plus y minus z is equal to negative 1. And in this case, my equation 2 is going to get left alone. So x plus 2y minus 3z equals 2. But on my other equation, I need to multiply it by something in order for me to cancel out. And since I'm trying to cancel out y's still, I'm going to multiply it by 2. And so that gives me 2x plus 2y minus 2z is equal to a negative 2. And I am going to add these to cancel out. And when I add these to cancel out, x plus 2x is 3x. Negative 2y plus 2y is 0y. Those cancel. Negative 3z minus 2z is negative 5z. And 2 plus a negative 2 is gone. Well, I can't leave that side blank, so I'm just going to fill it with the placeholder of a 0. This is my equation 5. So now I am at the point where I have 2 equations solved for 2 variables. I'm going to take those 2 equations, equations 4 and equation 5, and I am going to use those to see if I can cancel out for another term. So 4x minus 5z is equal to 5, and 3x minus 5z is equal to 0. If I leave those 2 alone and try to add them, I would end up with a 7x and a negative 10z. So that's not going to work. I need to change the signs on one of the 2 by multiplying by negative 1. And that will just change all my signs. So my new equation is 4x minus 5z is equal to 5. And then the second one is going to be negative 1 times 3 is negative 3x. Negative 1 times positive, a negative 5 is a positive 5z. And negative 1 times 0 is still just 0. So I'm going to combine those together, and I'm going to come up with a new equation. And so 4x minus 3x is just x. Negative 5z plus 5z is going to cancel, and that gives me 5. So x is equal to 5. And so I'm going to take these and I'm going to work it back up through. So I'm going to go up to this equation here, and I am going to replace x with 5. So 3 times 5 minus 5z is equal to 0. It didn't matter if I took equation 5 or equation 4, either one would work at this step. So 15 minus 5z is equal to 0. I'm going to move the 15 to the other side by subtracting. And that gives me negative 5z is equal to negative 15. Divide both sides by negative 5. That gives me z is equal to 3. So I now have x and z. I'm going to take that information and I'm going to go back up into one of my equations. And so with x and z being replaced, it gives me down to where I can work through. X was 5, so I'm going to replace the x with 5. Oops, that color didn't show up very well. Let me get a different one. Plus my y, I don't know yet, minus my z, which was 3. And so basically I'm working my way back up to combine. My negative 5, or my 5 minus 3, I can combine those two because there's no variable in either one. So 5 minus 3 is 2. So y, and it's plus 2 because we have it being positive, is equal to negative 1. Subtract 2 from both sides, and y is equal to a negative 3. So now I have my 3 that I have solved for. I have x equals x equals 5, y equals negative 3, and z equals 3. And so I come down to the very bottom, and I'm just going to give my solution set. 5, comma, negative 3, comma, 3, because I go in order, x, y, z.